Welcome to this mini video course on how to learn coding with Python. My name is Dave Tromp. I have a website at davetromp.net where I write about coding and trading, two of the things I do. And this mini course will be about learning you how to code if you have never coded before, using the Python programming language. You see here the website of python.org. So why did I decide to make this course? Well, I believe that anyone should learn how to code, because coding and computation is all around us in this modern day and age, and if you know how to code, you will understand the world better. What will you learn if you follow my mini course? You will learn the basic principles of programming using the Python programming language. I intended it first to be focused on traders who want to learn how to code, but I've decided that it's a bit of a narrow point of view, so it will be not too much focused on traders, but on anyone who is interested in learning how to code. For instance, I have had many colleagues, like product owners or managers in the software development business who do not know how to code, and many a times they wonder, how do these guys do this, these developers like I am. So for these people it's very useful to understand at least the basics of programming. Even if you have no intent to become a programmer, it's still very useful to understand how a program is built, how it's run, so you can have a better discussion with software developers. But also, if you have nothing to do with software development, programming is everywhere. It's in your television, it's in your telephone, it's in the banking system. So if you understand how this all comes together to work for you, by knowing how to program, you will understand the world better. So what do I expect that you know of programming? Well, nothing. So the prerequisites for this mini course is that you have no coding skills. If you have some coding skills, great. You will still learn something, I think. It is a prerequisite that you know something about computers. You at least know a bit more than just web browsing. Maybe you're very good at using Excel or PowerPoint or things like this. So at least you know how to get around the file system and the computer itself. If this is problematic, then first you should see if you can focus on learning these skills first. Python has two types of two versions. There's the 2.x version and the 3.x version. We'll be using the Python 3.x version. The current version is 3.6. So if you go to python.org, then you will see here downloads, and then you will see Python 3.6.0 and Python 3.7.13. You should download 3.6.0 and install it on your system. Python is cross-platform available, so it's available for Windows, Mac. Oh, yes. So you can download here the latest release. If you just go there and download the latest, let me see. down here at the files, you can see you will probably want the executable installer. This one for Windows, just click on it, it will download an exe file, and if you click on it, then it will open and start the installer. I'm working on Ubuntu Linux, so I cannot show you here on my computer. I will see if I can make a small demo of how to install it on Windows, because still most people are working on a Windows-based system. If you have Mac OS X, you can download this installer, and then you are good to go as well. Once installed, you will have a Python engine that can run on the command line, but you also have what's called idle. That's the IDE of Python. That will look something like this. And here you can type all kinds of commands, and we will get into this later. So if you have this installed already, great. If not, go to python.org and then go to downloads. If you're on a Windows machine, the download button here will immediately give you the Windows installer, and if you're on Mac OS X, it will immediately give you the Mac OS X installer. You see here is the Atom IDE. It's a text editor that I will be using also next to idle, and you can get it if you want to have the same setup as I have by going to www.atom.io. I will show you the website. There we go. And then at the first page, the home page, you will see a download button as well. And again, if you're on a Windows machine, you will be offered a Windows executable to install. And if you're on Mac OS X, you will get an image for installing it on Mac OS X. And as I'm on Ubuntu, I'm offered a .deb file. So so what I suggest you do now, if you want to follow me along in the next videos, is to go to www.python.org and install Python, and go to www.atom.io and install the Atom editor. If you want to see a video on how to install Atom on Ubuntu, I have a video made about this, and I will link this in the comments below. Well, that's it for now, and I will see you in the next video where we will start the mini course. Great, so you've decided to continue with this mini course and start to learn something about programming. Congratulations, that's a wonderful decision. I've made this decision maybe about 10 years ago when I was working with as a project manager on some software projects, and I was working with developers, and I was really wondering how these mostly guys were doing this, and I got hooked and taught myself how to program using the Python programming language, and you're about to do the same, and that's great. So this is lesson number 1, and in this lesson I will talk about some basics of programming, the basics of the paradigms that we have in programming, or some of them. There are many more, but the most important ones. And you will see how you can write your first Python program yourself. Mostly Python is programming in Python is what we will be doing here is all about scripting. We will be writing instructions for the computer to execute in a linear fashion. So we will say to the computer, first do this, then do this, then do this. That's what we call, or what I call, scripting, as I've written here. And that's the most we will do. That is what we will mostly do. If we want to take it a step further, we can do some procedural programming. That means that we will write some functions that we can execute later and that we can reuse. So we will have a more structured way of working. And then we will also briefly touch on object-oriented programming, because Python is also an object-oriented programming language. It can be used as a scripting or procedural language, but also object-oriented. And many of the standard library functions, so the functions that are already available in the Python programming language, use this paradigm, this object-oriented paradigm. And then there's also functional programming. There's a lot to do about this lately. It's becoming very popular, but we will not touch on this. But I did want to mention it here, so you have kind of a full scope of the most important paradigms that are available. So if you want to write your first program, it's standard in the programming world to write a hello world example. So that's just making the program output the hello world message to the console. So that's in Python 3 easily done by just writing print, which means print to the console, open a bracket, and then between single quotes or double quotes, in this case I use double quotes, write hello world and then close the quotes. So if I run this, it will output hello world to the console. So I will execute it right now. There you go. And then it says hello world. So that's the first program you can write if you just started to learn how to program. As you can see, I've run this within the Atom editor. So I've written my script on the left side, and on the right side the console pops up within the Atom editor. I've used a plugin for Atom to do this. It's the script runner plugin. Let's briefly go into how you could set this up. If you go to the settings, or let me see, usually I just use a command, no, control comma, and then it opens the settings page. And then if you go to install and then you search here for script, run scripts, enter, and then there's this package, the script package, and what I'm currently using is script runner. And I've already installed it, but you can if you have not installed it yet, you will see a button like this, and you can install it. Then if you use the Alt-X key, it will run the console and run the program or the script that you are currently in. So if I do this again, I close this out, I'm in this script, hello world.py, and I do Alt-X, then it will run it. So let's do this from scratch in the idle editor, because that's another way to do it. So if you open the idle editor, then you have the console, and here you can start typing things like hello world, and that will give an error, syntax error, because you have to give a command here. So if you write print, as we done in the scripted file, print, and then write hello world, exclamation mark, closing the quotes and the brackets, and then enter, it will put out on the console hello world. So I made a typo there, but that's not too important. Then another way to execute this is to put it in a file, like I've done in the Atom editor. So let's see how you can do this. So on the left top you have the menu, and you go to File, and then you do New File. It will open a editor. So you can simply write here what you've just written, print hello world. Oh, I've got the quotes, don't forget the quotes. Yes, and then you can do File, you can do Save, and you can just save it anywhere you like. Let's just call it hello, and it will get the extension py, need the extension py, so it can be identified as a Python program. Now if you press the F5 button, it will execute this program and run it. So as you can see here, it has run the hello.py file, and it prints out hello world. Let me just put it. So this is your first program, printing out hello world to the console. It's nothing much, you might say, but it's the first step in learning how to program. And in the next video we will go into how what you can do with text and working with text, because Python is very useful for working with text, and we will have a look at how this works and what's possible. So I hope to see you in the next video, and hope you enjoyed this video. Let me know in the comments below, and give a thumbs up if you like this series of videos. Thanks. Welcome to lesson 2 in Learn How to Code with Python. I've decided to take a step back and do it a bit slower, and only use the idle shell for now, because I think it's in the last video it was a bit, well, not messy, but maybe making it overly complex to show you two editors, and so you have to get a handle on that as well. So let's just work with the idle shell for now, and then when the scripts get longer, you will see that it's useful to start working with a text editor or an IDE. But for now, just let's focus on idle, the Python console, and start learning some programming. So this lesson I will show you how you can work with text in Python. So you've already seen how you can print out some text using the print function, but in the shell you can also type in a string, which is text, which are characters next to each other, and have it outputted. So we can do again the hello world example. You can see that I'm putting it in quotes, double quotes, and if I press enter, it will output it with single quotes. If I do it in single quotes, hello world, it will give the same output. So apparently Python understands that if you put something in double quotes or single quotes, it to be text, even if it's a number, for instance. So if you put the number 1 in double quotes, it will give back a string 1. Why I know it's a string? Because it's outputted back in the console with single quotes. If I would simply do 1 and press enter, then it will output a number on the console, an integer in this case. We've already seen the print function, so we could print out some long text. Hello world, how are you? And this will print out the text. You can see the difference here. There are no quotes around the text that's put into the console, because we are using the print function. So we're giving the order to the Python interpreter to output a string just as you would read it, and without the quotes. So what can we do with strings? Well, many things. First of all, we can look something up in string. We can see if string is in a string. So we can do something like hello world, how are you? This string, and Python offers the find method. So you can say find, and then you can look for something in it, another string, enter, and it returns 6. So what does this mean? It means that world has been found in the string hello world, how are you, at position 6. So this is the first letter, 1, 2, 3, 4, 5, 6, and then after that we have the set of string, the string that we try to find. So what else can I say about this? Interesting to know is that it found it on the 6th position, while actually the W is on the 7th position. That's because strings are counted from 0. So the H is on position 0, the E is on position 1, L is on position 2, etc., etc. So the W here is on position 6. Then let's see, what else can we do? We can replace strings. So let's say we want to replace world by another word. So we can use the replace function. So we want to replace world with something else. we can say hello Dave, how are you? So the first parameter that we give to the replace function is world. That's what we are looking for, and then we are replacing it by Dave. So this is a simple find and replace function. So if you press enter, it gives back hello Dave, how are you? Let's see what happens if the string cannot be found. So hello Maria, how are you? Maria is not in the string. It just leaves it as is. So in the replace function will look if it can find the first string and then replace it with the next. Let's see how this works if we look for something that cannot be found with the find function. So we go back to the find function and we look for Maria in the string. Well, what do you guess? What will it give back? Will it give an error? Well, let's see. Hey, it gives -1. So if the find function does not find the string you are looking for in another string, it gives -1. So you could use this in a script. For instance, you want to see if a whole text contains commas. You can look for the commas, and if the find function returns -1, you know there are no commas in the text. What else? We can also change the casing of the letters of the sentence by using lower or upper functions. So let's say we want to downcase the sentence that we have. We could use the lower function, and as you see, it's all lowercase now. In the same way, we can use the upper function to have it all in uppercasing. Yes, this is particularly handy if you want to look for something in a text, but you don't know if it's in upper or lower casing. So let's say we want to find world in this sentence, and but we don't know if world has been capitalized or not. So we could simply make it to lower, like so. Yes, and then immediately after it find in lower cases world, and then it should find it. So it transforms the whole sentence into lowercase. So world will also be in lowercase, and then we start looking for world, and then it should find it. So let's see if this is still true. Yes, it returns 6. So this is how to look for things in a long string of text. You can also add other things easily to a text using the format function. So let's say again we have the hello world example, how are you? But instead of world we want to add something here. We can use the format function, which is a very handy function. So at the place where we want to add something, we will use curly brackets, like so. So hello something, how are you? And this something, the curly brackets will be replaced by the something that we add to the format function. So here at format we put another string like Pete, just say name. So hello Pete, how are you? Enter. Hello Pete, how are you? Same way we can use Maria again. How are you? Also, instead of only one replacement, we can use many more replacements. So, hello Maria, how are you? But we can also hello Maria and someone else. How are you? So we can say hello Maria and Dave. How are you? So, hello Maria and Dave. How are you? To combine this with the print function, for instance, we can say print this out by using the print function. Print, and we have to close the closing brackets here. Enter, and it prints out hello Maria and Dave. How are you? Another very useful function is the or is it the function? It's a method actually. Doesn't matter. Operation we can do is the split operation on the text. So we can take this text again. So we have hello Maria and Dave, how are you? And we have a comma here, and we want to split this sentence into two parts, and we want to split it on the comma. We can use the split function, and we will split on the comma. Enter. Then you see the sentence has been split up in two, what we call two elements of a list, and we will get into this later. But this is how you can split text into two parts, and you can show only the first part by accessing the first element by using this way of writing. So the brackets with 0, that's the first element, and the second element is number 1. So here hello Maria and Dave. So if we want to access the second one, we press 1 here, and then how are you? Okay, so this is the base. These are some basic examples of how you can work with text. I hope you found this useful, and in the next lesson we will look at how we can work with numbers in Python. Okay, thank you for watching, and hope you liked it. Give me a thumbs up if you like it, so I know, and see you in the next video. Okay, welcome to lesson number 3, working with numbers in Python. So numbers, well, we've just looked at in lesson number 2, we looked at strings and what you can do with strings, and how they are being processed in Python. Now we will be looking at how numbers work in Python. So basically there are two types of numbers in general. So they're the what we would call whole numbers, like 1 or 5, and decimal numbers like 1.2 or 3.4. So these are different numbers, and these are treated differently in Python. So whole numbers are called integers in many program languages, and in the Python program language they are called int for integer, and the decimal numbers are called floating point numbers, or float for short. So This difference has some implications when doing multiplications and additions, etc. in Python. So let's look at this. So if we do 1 plus 2, 1 plus 2 equals 3. And it returns, as you can see, an integer. If you want to know what is the exact type that's being returned, you can ask for the type. So by actually typing type and then doing 1 plus 2, and then it returns class int. So you know that the result is an integer. So what will happen if we add a float to an integer? So let's say we do 1 plus 2.3. Let's see. That returns 3.3, which should be a float. Let's see if that's correct. So type 1 plus 2.3. That should return a float, class float. Yes, that's correct. But this also, the result is cast, as we call it, to a float when one of the numbers is a float. And this also happens if the one of the numbers is a float, which is a round number. So let's say we do 1 plus 2.0, so which is a round number, but the notation we use is a float. If we press enter, I expect it to return 3.0. Yes, 3.0, and that's a float. So in some programming languages you specifically have to give the type that you want for the numbers and also for the return value. But in Python it's being inferred. So if you say 1 integer plus 2.0, which is a float, then Python will automatically infer that it's that one number is a float, and then the result will also be a float. So this is also true for other operations, like let's say multiplication. So let's do 1 times 2.0 returns 2.0, while 1 times 2 returns 2 as an integer. Same is for division, but that's a little bit more tricky, as we can see. So if we do 1 divided by 2, let's see what this returns. This returns a float. So from two integers, the return value can be a float. Let's check if it's actually a float. I know it's a float, but let's just be clear about it. Divided by 2. Yes, that's a float. So if we don't want to have a float returned, we can use some functions like the round function. So we can say we want 1000 divided by 33. That's 30 something. But we just want to have the rounded value. In this case that would be 30. We can use the round function, round 1000 divided by 33, and that should return 30. And in this case an integer has been returned, so let's check for that. Type, yes, that's an integer. So what if we would want to have a float returned? Well, we could have this returned simply by making one of the numbers a float, like this one. No, not true. Sorry. Oh yes, of course. The round function, as its rounding function, only returns integers. Yeah, what's the point of making it float? So if you really would want to force the result to be a float, you could use what we call casting. We could cast the integer that's being returned by the round function. We could cast it to a float. So we could do this, float, and then it would return a float. So that would be something like if we want the integer number 1 to become a float instead of an integer, we could do this. The other way around, if we have a float and we want it to be an integer, we can also do this by using the int and then 1.0, and that would return 0 as 1 as an integer. So we can move from float to int and from int to float. You have to be careful, because if you have a float that's 1.5 for instance, and you cast it to an int, then you will lose the decimals. So 1.5 will become 1. Also 1.7 for instance will also become 1. So you will just lose everything behind the decimal. If you would want 1.7 to be an integer that's rounded up, so 1.7 becomes 2, then you should use the round function again, 1.7. Okay, so this is going back and forth between the types of the numbers. What else is there to know? Yes, of course, division by 0 is not possible. So if you divide 10 by 0, it will return an error, and that's called the zero division error, which is sometimes very useful to use. Let's see. Yes, powers, how to use powers in Python. Let's say 2 times 2, so 2 times 2. So the 2 to the power 2 is 4, is the same as 2 to the power, that's double star 2. Just to make this more clear, 2 to the power 3, that should be 8, that's this. 2 to the power 4, that's 16. And in the same way, we could take the square root, because the square root is nothing more than, let's say, the square root of 16 is to the power 0.5. And as you can see here, if you take the square root like this, you will have a float returned. So in this case, you could cast this to an int, just to get a integer 4 back. Let's see. One more thing that's already interesting to know: you can sum up a group of numbers. Let's say you have 1 and 2, and you have a 3 and a 4. Yes, and you want to have these summed up. That can be done using the sum function, and then you have to put them in square brackets as well. 1, 2, 3, 4, and it sums them up, and that's 10. Alright, one more thing, you can combine numbers with strings using the format function again, and that's something I would like to show. So let's say you want to say I have so many apples, and then format, and then you can say I have 10 apples. Enter, and as you can see, the 10 that has been that's an integer in the format function has been cast to a string automatically by the format function. So you don't have to, you can, but you don't have to enter the 10 here as a string. That's not necessary. It will work, but you don't have to. The format function does it. That was something I would like to show you still, and that makes the connection to the working with text. So these are the basic things you need to know when working with numbers that I can think of right now on the top of my head. That's it for now. I suggest you play around with it, with the things I've explained so far, and then we'll start using all these simple principles in the next lessons. Thanks for watching. Let me know if you like this video by giving a thumbs up or leaving some comments in the comment section below. Thanks, and see you in the next video. Welcome to lesson number 4 in Learn How to Code with Python. In this lesson I will show you how you can read in a file and how you can write to a file. That's a very useful thing to do because it allows you to take large pieces of text from somewhere or even numbers and to process them and then to write them out to somewhere else. It's a very common practice. In the process I will also introduce the concept of variables and storing data temporarily in it. So let's dive in and let's have fun. So I'm opening idle again to show you, and before we go in there I'll show you that I have just copied some lorem ipsum text, some old Latin text that is usually used to fill up some layouts of websites that are being designed. So here's the text, as you can see in this document, lorem ipsum.txt on my desktop. So how can we read in this file? Well, in Python that's fairly easy. We use the open command and then we type in the location of the file that we want as a string. So in this case it's on the desktop and it's called lorem ipsum.txt. Close off the quotes and the brackets, and then if we press enter, let's see what it returns. Well, as you can see, it returns not the text that's in the file, it returns what's called an object or a representation of an object, and it says that it says the name of the file, desktop / forward lorem ipsum.txt, the mode, it's in read mode, and the encoding of the file is UTF-8. So if you want to see the text that's in it, you simply use the .read method on the object, and then it will print out all the text to the screen, as you can see. So let's say we only want to have the first line. That's also possible because it's quite a lot of text. So if you only want to have the first line, you can use the readLine method, and this will return only the first line of the document. So there we have it. So if we want to do something with this, it's usually a good idea to use a variable and to store the text in it. So what's a variable? A variable is just a location in memory of your computer where you can store stuff, text, numbers, and other things. So a variable can be anything like variable and is, and then something you want to put into it. So I want to put in here hello. So what this does, it puts the string hello in a location in memory, and I can call this location by calling the variable that I called variable. So if I type now variable, then it returns the string that I've just put in it. Variables can have variable names can be strings, lower cases, and I believe not anything else. So no @ symbols, no hashes, no exclamation marks, or no question marks. So there question mark is, let's say, 1. That gives a syntax error because that's not allowed. But I can have variable 1 is 1, like so. And I can also have var 1, like so, is 1. And then I can call it var 1. Okay. So those are variables. Variables are places in memory of your computer, or references to places in your in the memory of your computer where you can store strings of text, numbers, other stuff that we'll get to later. So let's put in the first line of the document into this variable, or into a variable. Let's call it var2 is open. Let's do it. I don't like to type too much, so let's take it from memory. var2 is open read line. There you go. So now the first line of the text in the document has been stored into memory, into a location that I can reach by asking for it, typing var2. There you go. So now we've taken the text from the document, and now we can start transforming the text or splitting the text. Let's say we want to split on commas, like we've done in the lesson number 2, I believe it was. Then we will just do the variable 2 and we'll split it on comma, enter, and then you see you get back what we call a list with all the pieces of text that could be separated by commas. So if we want to write, what we've done so far is reading from a file, but it's also very useful to write to a file. So let's say we want to write the var2, so the first line of the document. We want to write this to a new document. To do this, we have to open a new document, and the document that we've read in, that was opened in read mode. So let's go back to that. So if we just open the document, it says here the mode here is R, that's for reading. So there are different modes for opening documents. You can open it as we've done here with no indication of how we want to open it. Then Python just opens the document in read mode. But we can also open a document in append mode. That means that we can add stuff to the document, and we can also open it simply in writing mode. And we can then, if the document exists, then it will be emptied and everything will be added to it anew, and then written out. So let's open a new document in write mode, and let's save that the object that we open into a variable so we can reach it. So let's say document is open, and then we'll put it on desktop again, desktop dash new.txt, and then here in single quotes we will use W for writing. So this will instantiate a new document object that we can reach by the document variable. So what can we do here? If we call it document, then we get here a representation of the document. It's in read mode and the encoding is UTF-8, and the document has also been created here on the file system, and it's empty, as you can see. So now we can write to it. So how do we write the text that's in var2 to this document? That is simply done by writing it to the document like so. Document, that's the object that we have, dot write, and then what we want to write to it, var2. So this tells Python, the interpreter, to take everything that's in the variable 2 and write it to the document. Okay, so now it's written 869 characters, is that so? Or is this the location? Not sure what this is actually. Anyway, it's written to the document, but now we have to close the document to have it saved, and that's done like so. We do document. First let's see the text document. It's still empty, as you can see, because it's not written to it yet. It's only in memory. It's in the document object here. So now if we close it, enter. Now, as you can see, oh, it's bytes. So the 869 here that it returns if you do document.write, that's bytes. You can see here it says bytes. So 869 bytes have been written to the text document. So let's check. Yes, there it is. Our first line from the lorem ipsum document has been written to the new text document. Num eget dwi, num eget dwi. Okay. So this is how you read text from a document, and then you can do something with it. Just take the first line. You can do something more with it. You can split it. You can transform it any way you want, and then write it back to another document. So that's how this is done. It's a very useful thing to know. I'll leave it at this. This is still part of the basics, and in the next lesson we will have a closer look at the different data types that are not only related to text and numbers, integers and floats, but there are other data types that you have already seen a little bit, like lists, that I will explain in more detail. And after that we can really get going and start doing some more interesting things. So I hope you found this useful and interesting still, and let me know by giving a thumbs up and leaving some comments in the comment section below. Thanks for watching, and see you in the next video. Okay, this is already lesson number 5 in Learn How to Code with Python, and in this lesson we will wrap up with the basics that you really need to know before we can take the next step. And I will be talking some more again about variables. We already looked at variables in the previous lesson when we were using it to store data from a file and then writing it out again. But there's another important connected principle, and that's principal thing you need to know, and that's data types. So what are data types? You've already seen some of them, like the string, so the hello world example. Hello world, this is a string. So if we use the type again, that's actually the data type that it asks for. Type hello world, that gives back string. So the type for 1, I really need to learn how to type better. Type 1 gives int, and then type 1.0 that gives back, well, you know, float. So these are the 3 types that you've already seen, string, int and float. And what you usually see is that data in some form of data type is temporarily stored into a variable and then being processed and then written out to somewhere again. So that looks something like this. Variable 1 is 1, and it means that data, in this case the number 1, with the data type integer, is being stored in a location in memory, and that's being referenced by the variable with variable name var1. So var1, if I type this, then in the background the computer or the Python interpreter will match this variable name var1 with a location in memory where the data, in this case the number 1, is stored, and that's why the interpreter returns the number 1. Strings, integers and float are fairly simple data types and have a very simple structure. There are 3 other data types that I want to discuss that are very useful, and the first one you've seen also already, and that's called the list. And the list is, as the name already says, it's a list of variables that are combined together in a particular order. So a list can be something like this. Let's first let's say we have the var1 that we already have, and also we have a var2, and that's the string 2. So we have var1 and we have var2. Yes, we can put these 2 variables, one of them is an int and the other one is a string. We can put them together into a list. So a list is and we can and this, well, let's first put it in a list before we continue. So we can say var1 and var2 like this. This is a list, so the square brackets make this a list. So if I press enter, then you can see we have a list 1, string 2. And this list can also be stored into memory, so we can reference it later. So we can say list 1 is the list of var1 and var2. So this returns nothing, and then later on we can call it again list 1, and we have it again. So that's a list. Then what's the best thing to explain? Let's show a practical usage of this. Let's read in the document that we had, doc, and then we'll open the document. Oh, it's on the desktop. What was it? Lorem. Oh, there it is. Oh, lorem ipsum.txt. So we read this into doc, and if you want to see the first line, you just do read line. Oh, typo. Read line. So there it is. So we've seen already the split function that we can use on documents, and that returns a list. And I didn't point it out too clearly because I hadn't explained lists before, but now you know what a list is. So let's say the doc has a list, and so we read in the first line of the document, and we will split it on a comma. So it will split here, and it will put this text as the first element of a list, and then this of the second all the way to the next comma, which is here, and then it will take this one as the third, etc., etc. So let's see what that will look like. So now if we ask for the doc list, doc read line split comma, what's going wrong here? We split on the comma. Oh yes, the readline function reads in the line, and then if you call again the read line, it reads the next line. So let's see, how can we fix this? We have to close the doc and then open it again. Oh. So there we go. So if I, just to show you, if I do doc read line again, here it just gave back a line break. This is a line break, this here. So if I do read line now, it will give the third line of the document, because it's the third time I will call read line. So if I do read line, you see, this will be the third line. Let's just check. Let's show you. So this was the first line, the read line. This was the second, and the third time that I called it is this one. So if I call it again, it will give a blank line again. And there we go. Let's just show you while we're at it. read line, and then again read line, the next line. So read line calls line after line after line. So how will I proceed? Now it will give, so the next time, this one here, this is a line that will come back, and now I will store it into memory. So now if I call this line, I can call it again. So let's split this line, and I'll put it into line split variable, and I'll do line dot split. And now line split will is a variable that references a list of this line, of this text, that's being split by a comma. So we will have a list that contains this part and this text as an element, this text as an element, etc. So let's have a look. So line split looks like this. So here you have it. It does not include the commas in the text because it's been split on it. So this is one element, this is one element, and this is another element, etc. So let's say we want to have want to print out only the first element, line split, and then only the first element. The first element can be referenced by using square brackets, and then the first element is the 0 index. So let's go into lists and indexes a little bit further. So if we have a list like 1, 2, 1, 2, 3, 4, okay, then 1 in this case is on on the 0 index of the list, 2 is on the first index, 3 is on the second index, and 4 is on the third index. So list items can be called by referencing their index, so their position in the list, and the first item in a list is always on the 0th index. So lists are 0 indexed. So if I want to call just number 1, then I can call it by calling and referencing the 0th index, like so. If I want to call number 2, I do the first index. Number 3, second. Oh. For good measure, the last one, number 3, like so. Okay, I'll leave it at this for now. There's a lot more to be explained about lists, but this is the most basic stuff you need to know. And let's have a look at some other data types that are also available. So we had string, we had int, we had float, and now list. Then number 5 is the dictionary, or dict. And let's just give you number 6 as well already. That's the tuple. Is it written like this? Tuple. Anyway, so let's first look at dictionary. Dictionary is, as the word says, it's a handy data structure for looking up data. And a dictionary in Python is written like this. So if you have my dict variable, then a dictionary is created by using curly brackets. So this is a dictionary which is currently empty. So if I call it my dict the empty dictionary is being returned. A dictionary is basically a key value pair storage. So with the list, you can retrieve a single element from the list, like say here number 4 I can retrieve by referencing the position in the list. With the dictionary you do not reference a position but a key. So what that looks like this. So if I mydict2 is a dictionary, and then the key is a string or something else, an object, can be anything, but let's use a string. So well, let's say my name, and then that's the key, and then my name is Dave. So if I want to get the value Dave, then I can call the name on the dictionary, the key name on the dictionary. So mydict2, and I'll call the name, then it returns Dave. So this is a very handy tool, because you can of course have many things in it, like name, last name, address, and then you can quickly get someone's address just by going to mydict and then address, and then it returns the address. So this is very useful if you want to quickly retrieve data, instead of when you could also store this, of course, in a list. You could do my list is, and then you could say Dave, yes, and then you could say, okay, the 0 index is always Dave. But it's much more easy to say, okay, I want to get the name, so I call the key name, and then you get the name back of the value back that's stored on their name. Again, also here there's a lot more to say about dictionaries, how to use them, when to use them, but this is just a short explanation of what a dictionary is. Then the last thing to finish up I want to show you is a tuple, and the tuple is kind of like a list but not quite. So let's create a tuple, and then I'll start explaining. Tuple, is it tuple P? Anyway, tuple, and a tuple, instead of like the list that's being created with square brackets, you create a tuple using round brackets, 1, 2, 3. And it's similar to a list in the sense that you can access the positions, the values in the positions. Like if I want to get the number 1, I can do my tuple 0, like so, and then I get back 1. However, there is a difference between tuples and lists, and that's list can be altered and tuples cannot be altered. In fancy terms, we would say lists are mutable and tuples are immutable. Also, I won't go into all the details about this in this lesson, but just to recap, what do we have as data types? We have floats, integers. Well, let's start with string. We have the string. We have integer. We have float. We have integer, string, integer, float, list, dictionaries, and tuples. So these are the 6 basic data types that you will come across when using when programming in general, but especially in Python. That's it for now. This was lesson number 5. I hope you like this lesson, and I'll see you in the next lesson. Thanks for watching. Hi there, and welcome to lesson number 6 in the series Learn How to Code with Python. Up till this point, I've shown you some basic principles of coding, and I've showed them while using Python. And in this lesson, we will go into some specific Python things that you need to know. For instance, where the place where we type the Python commands is called the interpreter. Sometimes I've called it engine or something else, but in general it's called the interpreter. It interprets what you type and then processes it in the Python interpreter and gives you back something, or it processes something and gives you something back in the console. Up to this point, we have not used any extensions to the Python library. So let me explain how this works. There is something which is called the standard library. So there are many pre-set functions that you can use that are already built into the Python interpreter, but they're not loaded by default. You need to import them if you want to use them. So to give an example, if you want to work with the things with the OS, you can do, for instance, an import by typing import OS, and that will load the OS module. This is part of the standard library, so you don't have to install anything extra for it. When you install Python, this is already included among many other libraries. So once you have imported a library, you can start to use it. For instance, you can see if a file exists, for instance. So you can do OS, that's part of the OS library, OS, and then path exists. So here path, and then you can do isFile, for instance, isFile, and then you can type the path of a file, and then if if it's a file, it will be returned. So let's see, what do I have here on my desktop? The lorem ipsum, that's a file. So if we say desktop dash lorem ipsum text, there we go. Oh, lorem ipsum.txt. This is a file, so if I press enter now, then it should return true. So there you have it. Now I've confirmed that this file exists and that it is actually a file. So that's one of the functions that is already built in in the OS module. So there are many more modules. If you press F1 while you're in the console, in the idle console, then the help page should open. F1, there we go. Oh, I have to be in it. F1. Let's go and see, go to help, Python docs, Control H it says, that works for me as well. So Control H brings you to the Python documentation where you can find all the tools that are already built in, library reference, and there's built-in functions. These are built-in functions that you can call without importing modules. So we've already used, for instance, the sum function. There we go, sum function. You can read up here about it. So if you go back, so let's talk a little bit more about modules that you can import. If you want to see which models are available, you can press Ctrl H from within the console, the idle console, and then it will open the Python documentation of your version in the browser, in your default browser. Here you can find and look up all kinds of things about Python, like the history and license of Python, etc. I suggest you take a look at that. But at the right hand corner there's a modules link, so if you click there you will go to a list that lists, well, all the modules that are included in Python, in the standard library. So if we scroll down to the O, then here we will see OS and OS path. That's the one that we've used before. So you can click through there and you can look up what's available, how it works, and it's quite extensive, and most of them you will not use immediately, but over time you will learn the most important ones. So that's where you can look up all the modules that are available, and I suggest you take a look at that. If you are working on, I wanted to explain you about the standard library, and I wanted to show you some examples of how to use it, and I wanted to show you some overview. So I had to look up in the documentation the standard library, and then I came across a brief tour of the standard library. I'll add this link to the description of this video, so you can look it up yourself. And here you see some examples of what's available. So we've already seen import OS, and then with os.get cwd means current working directory, how it says here, it will show you in which directory you are. So if we try this ourselves in the console that we have open, so we have already imported OS, and if we do os.get current working directory, then it will show you my home directory. So that's where we are currently at. So let's see what else they have. Dir OS returns a list of all modules. Yes, that's also interesting to show you. If you use the dir command on a module, it will show you all the available functions that are under it. So let's walk through this quickly. So we've, like for instance, the change dir command, chmod command. Change dir command is to change the directory. So if we do os.change dir, and then let's go to the desktop, for instance, desktop, and then if we check for the current working directory, we are at the desktop. So from within Python you can manage your operating system or the file system with this module. Okay, so if you, I think you should research the documentation yourself and see what's available. We will get to more of the modules at a later point. And for now, one of the specific things about Python is also that Python uses code indentation. So let me show you that. So I want to show you about code indentation. That's something that's typically something for Python, which makes it different from other programming languages. So I thought I'd just show you some of my code so you can get a feel for it and understand what I mean. And at the same time, you can also see how the import of modules what it looks like. So this is a piece of code that I've written. It's for a website, and you can see that some libraries are being imported, like for instance here the regular expression library, which is part of the standard library, math for doing mathematical operations, itertools for the time module, etc., etc. So that's what the imports look like, and the indentation is what you see here. So instead of using brackets, what you see in some programming languages like brackets like this, Python uses indentation. And so if we go to the next line here, let's say we define something like a function x, and then instead of doing what you do in some languages, you do like this, and then you start typing something. And at the same time you could also define it like this, and then usually they have a semicolon to say this is the end of the statement. Python doesn't use all these semicolons and brackets. It just uses new lines to and the indentation, which means the tabs. Or actually, these are not tabs, these are spaces. In this case, 4 spaces is one tab, and another tab is again 4 spaces. So, and this gives a clear view of how a program is structured. So, it's very easy to see where this if statement ends. It ends here. Well, if you have, if you use brackets and semicolons, you can also make your code look like this, but you don't have to make it work. And because Python makes you format your code like this, it makes it very clearly readable, and there's no other way to do it. And that's very specific for Python. So especially if you're a beginner, and you really have to program it like this, then you make your code very clear from the start. While if you can do it in a different way and your code still runs, then you will learn probably some bad habits. So that's a nice thing, and a very specific thing about of Python. Another thing that's very typical of Python is that it's what we call a dynamically typed and strongly typed language. Well, what does that mean? Let's have a look at that. Dynamically typed language means that if you set a variable, it will only be evaluated at runtime. So I can say, for instance, a is 1, and then at runtime the interpreter decides that a must be an integer. So I don't have to specify beforehand, like you have to do in some languages, that you have to say int a, that you have to say, okay, I want a to be an integer, please reserve some integer space in the memory. Now you don't have to do this before, so when the program compiles, because Python is an interpreted language, so at the time that the code runs, when it comes to a is 1, at that moment the interpreter will interpret a as an integer, because it's reference to 1, which is an integer. So that's dynamically typed, but at the same time it is strongly typed. And what that means is that if you have a is 1 and you have b is a string 2, if I do a plus b, it will give an error, because I cannot do addition with a string and an integer. Well, in some languages like JavaScript, for instance, if you do this, then the 1 will be transformed in the background from a integer to a string, and then the result will be a string of 1, 2, like so. But this can give some unforeseen bugs easily if you don't know what you're doing, because without you explicitly saying that a has to be transformed to a string, the interpreter is transforming it then. So Python doesn't do that. If you want to add these up, you have to explicitly say that 1 has to become a string. So that's the a variable. So you have to do string a. So we cast it to a string, that's what it's called, and then we do plus b. Then this will give the result 1, 2. So that's strongly typed and dynamically typed. So dynamically typed, to recap, means that at runtime the variable type will be evaluated, and strongly typed means that the type of the variable will not be changed in the background to fit some purpose. You have to explicitly do this. Let me see, what else did I want to say about the specifics of Python. One of the things that I like about Python is this clarity, that the dynamically typedness gives a lot of freedom, while the strongly typed behavior of Python makes it that you don't introduce silly bugs, and the indentation makes the code very readable. So those are two very good things that I like about Python. And what I also like about Python is the way of thinking about how to code, and I will introduce you now to the Zen of Python, which are 20 lines statements that might not make too much sense at this time, but if you are programming for some time, you should read this again, and then it will make some sense. And I will highlight a few of the statements. You can read the Zen of Python by typing import this. It's a kind of Easter egg in the interpreter, and then you see this Zen of Python. Well, I'm not going to read through all of them, but the ones that I do like is readability counts. So that has a lot to do with the same philosophy that's behind the indentation. So it's more important to have readable code than have really condensed code. Sometimes you want to write codes that's short, but if this means that readability becomes less, then it's better not to do this. And I like that one very much. In the same way, there should be one, and preferably only one obvious way to do it. If you're writing code all by yourself, you might figure out your own ways of doing stuff. But if you write code in a team, this becomes very critical. That it makes it easy to have one way of working that everyone follows. And the line beneath that is also interesting to me personally because I'm Dutch. So it says there, although that way may not be obvious at first unless you're Dutch. It's a reference probably to the creator of Python, Guido van Rossum, who's also Dutch. So it's an interesting way of looking at the world. So I suggest from time to time while you're programming you read through these statements, and it will become more clear to you what they mean, and you will start to understand the deepness of it. Okay, so this was about Python and what makes it different from other programming languages, and I hope you found this interesting. If you did, please leave a comment below and give it a thumbs up, this video, and I'll see you in the next video. Okay, so welcome to lesson number 7, and in this lesson I will explain you about flow control. That's what makes your program make decisions, and it's fairly simple to understand, and I'll show you some examples. Let's first open a file. So we will stop working with the console directly, and we'll start working in a file that's a little bit more convenient. So we go to File and then New File, and then this opens a file that we can edit. So I'm gonna save it for now. Save as let's call it just flow control .py. Save. Okay. So flow is all about doing something when something happens and doing something else when something else happens. So this can be easily done with if and else statements, and it looks like this. So we can, for instance, have a variable a, which is set to the number 1, and then we can write if a is bigger than 2, then print something. So we can say a is bigger than 2, and if this is not the case, else, then we'll print a is not bigger, a is not bigger than 2. Okay, so let's run the script, and we can do so by pressing F5, and it asks if the script must be saved. Yes, and then a is not bigger than 2. That's what it writes. I'm going to put this on the right hand side and this one on the left hand side, so it's easier for you to see how it relates. So so if we change a in the script to 3, then it should print a is bigger than 2. Well, let's see. F5. There we go. A is bigger than 2. So this is a fairly simple beginning. But you can also add some more possibilities. So if a is bigger than 2, we want to print a is bigger than 2, and then we can do what is called an elif. So we can do another if statement saying if the first if statement was not true, then evaluate the second if statement, which is the elif. Elif a is, let's say, smaller than 0, then we print a is smaller than 0. Yes. And if that's not the case, then if nothing else is could be checked, then we print a is not bigger than 2, which in this case should be is not bigger than 2 and not smaller than 0, or in other words, it's between 0 and 2. So if we run this, we will still get the same answer, it's bigger than 2. Just to show you, F5, save, a is bigger than 2. So let's talk also a little bit more about how you can make comparisons in these if statements. So you can do if a is bigger than 2, but you could also say if a is bigger or equal than 2. So that this would evaluate to true if a is 2 or 2.1, 2.3, etc. But we could also say, let's just delete everything here. We could also use a negative expression. So we could say if a is not 3, then we will print something, print 1. So the exclamation mark is a negative, yes, and at the same way, if we want to do a comparison, we do double is sign. So here one comparison sign, or no, one is sign means assign the value of 3 to the variable a. But if we want to check if something is true, if a really is 3, then we have to do double signs, because if we would do like this, it would be assigning. So if I would run this, we would get an error. Let me show you this. It says invalid syntax. Yeah, because this is not correct syntax. You cannot set a value to a variable in an if statement. You can only compare. So just to show you that a is 3 evaluates to true or false, we could write something like a is 3. Yeah, so we've set a to 3 in the console, and then a double is sign 3. So that's a comparison. That's checking if a is actually 3. If this is true, then it will say true, else it will say false. So here it says true, which means this if statement here would evaluate to true. So this is true. We could also say if true, print 1, or if a is 3, print 1. So if we run this, it will print 1 to the console. Yes, so if statements compare to Boolean value, see if Boolean values are either true or false, and if true, it will do what's in the if statement below, else it will skip it. So Let me see what else I wanted to say about this. Yes, we can also see if a value is part of a list of values, for instance. So let's say we have that A is not a value, but it's a list of different values like 1, 2, 3, and then we want to see if 5, if this is in the list of values. If it's in there, we want to print out 1, else not. So if we run this F5, it does not say anything here below. But if we check if 3 is in the list, then that should evaluate to true and print 1. So let's run that. And there you have it, it prints 1. So you can check for values in a list, or you can check if a variable has a certain value, and then based on that do a certain action. So that's flow control, or at least the beginning of flow control, and I hope you like this lesson. If you liked it, please give it a thumbs up, and write some comments if you have some questions or want to see some more about flow control. And thank you for watching, and see you in the next video. Hi, this is lesson number 8 and of the mini course Learn How to Code with Python. And in lesson number 8 we will look at looping. One of the powers of computers is that it can do the same task over and over again with high precision, much more than human beings could ever do. And one of the constructs to make this happen in a computer is by initiating what's called a loop. So let's see how you can do this in Python. Basically in Python there are two kinds of loops. There's the for loop and the while loop. So if you want to let's start with the while loop, which is the most simple. And for instance, you can continuously, without ever stopping, let the computer do something by saying while something is true, so maybe just true, print 1 to the console. So if you run this, Python will print out the number 1 to the console continuously with ever stopping until we stop the program. So if we run this by pressing F5, it will continuously run and run and run and run and run until we press Ctrl C, and we've interrupted the program and it will stop. So this is one of the powers of loops, but it's also one of the trickiest things of loops is that it can go on forever and ever without stopping. And sometimes if you're programming and making some very complex programs, you might introduce something that's called the indefinite loop. So without having the intention, the program will continuously do something and get back, and then do something again and get back and do something again, and which eventually might even crash a computer if it eats all the resources. But for now, let's say loops are very useful, and we could make the loop not indefinite by using flow control. So we can introduce what's called a counter in a while loop. So for instance, we can set the variable count to 0, and then we can say while the variable count is less than 10. So that's similar to the if statement. So while the variable count is less than 10, we want to print out the count itself. So print out count. So if we run this, it will again forever print out the count, which is 0. So what we want to do after printing it out is adding 1 to the count. So we do count is count plus 1. So after having printed the count, it will add 1 to the count, and then it will go back. It will check again to see what the count is, which is it's 1, and then it's 2, and then it's 3, until it's 10, and then it will not will get out of the loop. So let's run this and see what it does. So it prints out the first count until 9. So let's see why only it prints out until 9. So let's say the count is 9. At this time it's still less than 10, and it prints out 9, and then here the count becomes 10, and then when it checks here, count is 10, which is less than, is not less than 10, because it is 10, and then it will stop, and it will not execute the print statement, and it will not add anything, and then it will continue one line lower. So to show you that actually after the while loop it breaks out and it continues, I will put another print statement here, and we will call this end. So after the while loop has finished, it will continue with the script and do whatever is there, and it will print out end. So if I run it again, it prints out 0 to 9 and then end. So that's the while loop. Another useful looping mechanism is the for loop, and it's particularly handy to loop over a list of values. So you can say, for instance, for a number in a list of numbers, let's say 1, 2, 3, 4, 5, print out that number. Yes. So what this will do, as you might guess, it will print out number 1, 2, 3, 4, 5, and then it will continue on the next line, and it will print end. So let's run this. So 1, 2, 3, 4, 5, and then end. So a for loop is very handy to loop over a list of values and then do something with those values. So those were the for loop and the while loop, both very useful looping constructs that let you do operations for a certain amount of times or indefinite times. I hope you like this lesson. I am sure it's very useful to know this. Let me know in the comments below what you think about it, and if you like the video, give it a thumbs up, and I'll see you in the next lesson. So welcome to lesson number 9 in the mini course Learn How to Program with Python, and in this lesson we will look into functions. But first let's do a little recap, because in functions we bring everything together and structure our code. But let's look at what we've done so far. So I've spoken about and explained about variables, how they work and what they look like. We've talked about data types, the strings, the ints, the floats, lists, dictionaries, and tuples. I've told you about Python specifics, like the interpreter, the standard library, where you can find some more modules and import them and have extended functionality. I've explained that Python is a dynamically and strongly typed language, so you should know what that means by now, and what that will do for you. We've spoken about flow control, making programs make decisions, and we've used comparisons in these decisions made by if statements. So we've compared bigger than, smaller, or bigger, smaller, the not, the negative comparison, and the is equal comparison, and the in to check if a value is part of some other set of values. And then finally we've looked at how you can make the program do repetitive actions with looping, the while loop and the for loop. So until this point we've written code in a very scripting kind of way. So the Python interpreter starts at the top of the script that you've written, and then line by line it interprets the commands and processes them one by one. And what functions allow you to do is to capture and group together a set of commands that have a specific function. So in Python, a function is created by using the def keyword for define. So I can define a function that I want to loop 10 times. That's how I will call it. So I give it a name, loop 10 times, and then we use opening and closing brackets, and we can continue with a colon and then press enter. And then I can say, okay, I want to make a function that loops 10 times and prints something out. So I can do, I can set a count again. So the same code we had before, count 10, count is 10, and then we say while count is less than 10, we will print the count. Like so. And so we have grouped this code that we had before now together and put it into a function. So if we run this, let's see what will happen. And nothing happens. And that is because we have not yet called the function. So we have created the function, and to make this function execute we have to call it like this. So we do loop 10 times, and like this we call it. So we've first created a function in which we put some code that we want to be executed, and at the end of the script we will call it, and now it should print out 0 to 9. So let's have a look at that. Save. And okay, so I actually made a small mistake in the code here. That happens, and that's the nice thing about the Python interpreter. It immediately gives you feedback, and you can see what that what you've written doesn't work, and you can fix it. So what I had here was count 10, and of course if the starting count is 10, then it's never smaller than 10, so it will not print anything. So let's remove the calling of the loop, of the function loop 10 times and set the count to 0, the starting count. And then if we run this, as you will see, it will not print out anything because we haven't called it. And then if we call it loop 10 times and then run it, and again I made a mistake. So we've created the indefinite loop because we didn't add another one to the count. So count is count plus 1. So this time we should have a properly working function that counts from 0 to 9, and we call it with the loop 10 times call. So let's run it now, and there we have it. So the nice thing about creating functions is that with the same code you can make different things happen by simply changing the parameters that you will give to a function, because a function can take parameters. So let me explain this. So let's say we do not want to loop 10 times, but we want to loop x times, like so. And then we can give here x as a parameter, and then at the while count we replace the 10 with x. Then it should run x times if we give the parameter here. So let's say we want to have it run 20 times, we can say loop x times, and then we give the parameter value of 20. So what will happen is 20 will be given to x, so the comparison count will be compared to the value that's in x. In this case it's 20. So if we run this, you can see that it runs from 0 to 19, which is 20 times. Just to show you how this can be changed, we can make it run only one time. It will only print out 0, and we have 0, but we can also have it print out 10,000 times, or maybe 1,000, 100, just to keep it short. And you see it will print until 99. So that's one of the great benefits of writing functions. Functions make it possible for you to reuse your code, and you can give parameters to a function so it will behave slightly different, but with the same logic. Another great thing about writing your code in functions is that you can organize your code. You can imagine having like 10,000 lines of code in a program, and if you do not group your code into functions, it will be really difficult to understand your code. So by writing functions, you can group code that does some specific thing. You can group it together and you give it a name that you can understand, like loop 10 times or loop x times. That tells me that if I call this, okay, something will loop x times. So I don't have to read the code and see what it does. I can just read the name of the function and I can understand what it does. If it's a very complex function, you can also write what is called a docstring. So immediately under the function name you can use triple quotes, and then again triple quotes. I usually do it like so, and then here you can write something about the function. You can write something like this function takes a value and loops as many as the value indicates. So this will not interfere with the program, what's between the triple commas, but if someone is reading through the code, they can read here and see what the function does. So just to show you that it does not interfere, I will call it again. And you see it just runs and does not print anything to the screen. So that's the basic structure of function. It's very useful, and by now I think you have all the knowledge to build some very complex programs, and in the next lesson I will talk a little bit more about what you can do and how you should go about it, and maybe give you some examples to get you started. So I hope you like this lesson, and I'll see you in the next lesson. So, and welcome to lesson number 10 in Learn How to Code with Python. And in lesson number 9, I already said that by now you have all the skills that you need to build something useful. And in this lesson, I will see if I can show you something interesting that you can build yourself with all the knowledge you have. And as an example, I will show you how to get some data from Yahoo Finance and store it on your machine for later usage. So to show this, I've opened the Yahoo Finance page on the S&P 500 historical data tab, and on this tab you see all the prices of the last few months, and you can download this data. So you can download this just by clicking it. It will download it to your file system, and then you can use it. This is how you would do it manually, but I will show you how to do this with a Python script. So let's click on the link and to get it. We'll copy it and then go to the script editor. And what I will do first, I will say the URL that I've just copied is this one, closing the quotes. And then to download data from this URL, we will need to import a library, and that is the URL lib library, and .request .request. You can look up which libraries do what by going to the documentation. Let me show you. You can go to Python docs. It will open in the browser the Python documentation, and then you can go to modules, and you see all the modules. Of course, you need to know which one you should use, and I will probably make some videos about some useful libraries for you to use. And in this case, I'm showing you to use the URL lib library, which is down here at the URL lib. We're using the request library, and here you can read what it does. But I will show you what it does and how you can use it in the most simple way. So we will save the data to a variable, store the data to a variable, and we will do this by calling URL lib .request .url open, and then we will open the URL. So this will create a object of the call to the URL and store it in the data. So if you run this, it will not show anything, but let's just see if it runs. Yes, no errors, so everything is fine. So let's see what we have taken from the web. by printing it out. We will print out the data. Oh, data. Let's see what this does. Okay, so it prints out the string representation of a request, of a response. Yes, so that's not very useful. So we do not want to have the string representation of the request. We want to have the value that's in it, and so we need to read it. So we need to read the data, and that's done by the read function, calling read on data. So we will read the data, and this will be printed out. So now I expect a whole list of data to be shown on the screen. Let's see if that's correct. And there you have it. That's data from Yahoo with the date, open, high, low, close. Okay, so far so good. Now let's structure this this code a little bit, and also add the functionality that we will write it to a file. Let's first implement the writing to the file. So to do this, we will instantiate a document by doing open, and then this is let's say Yahoo Finance .csv. It's a comma separated data, and we will make it writable. Yes. So this opens or instantiates an object with a file on the file system, and now we will write the data to this file, which we will do like so. We will do doc.write data.read, and then we close the document. Doc.close. So we don't need the print statement anymore. I could delete the print statement, but using the hash I can also comment it out, and it will not be executed, but only readable for me. So let's put the code a little bit close together in one block. So let's run this first and see if we indeed have a file that's called Yahoo Finance and that the data is in there. So let's run it. Type error, write argument must be string, not bytes. Okay, so we have to data.read, and we make it a string. Yes. Let's run it again. Okay, let's see. My home folder. Do we have a file here? Yahoo Finance. Yes, here it is. And let's open it. Let's open it in a text editor, and there we have it. Okay, this is not the way I expected it to be. Let's see if we can open this in LibreOffice. No. Let's do it differently. So let's read it line by line. Yes, let's comment this out. Let's not write to the document, but let's read this document in a loop, line by line. So let's say for each line in data dot read lines. You haven't seen this before, but the read lines will read in from the request that's been handled, and it will read it into a dictionary. So if we print here the line, then it will read the data line by line and we will print it out. So let's check this first. Yes, there we have it. We see that it has new lines, so we can get rid of these new line symbols by stripping it. Dot strip. Let's run again. Okay, so there's no new lines anymore. And what I also notice is that the data is in byte format, so it's printed out and we can see it, but the B here means that it's byte. So it's binary form and not in string form. So let's see if we can cast it to a string. No. So I had to figure out what was going on here, and in order to get the data type transformed to actual text of the data, we have to decode it. That's something I hadn't seen before. So that can be done by using the decode method. Decode to UTF-8, like so. So now what we've done here is we go through the data line by line, and we strip all the new lines from it, and then we decode the line, which is in byte form, and we decode it to UTF-8, so then it becomes text. So let's check this. And as you can see now, it's just text. So actually we don't need to go through the code line by line. So let's comment that out. And let's go back to our previous setup. Hope you're still with me. So here we have the data that we read in, and instead of casting it to a string, we need to decode it. So we do not decode it, but we do not cast to a string, but we decode it. So this should write to Yahoo Finance the string of what's in the data. So we read it, we decode it, and then we close the file, and we take it from the URL. So let's run this again. Okay, so that doesn't give any output, but now this file should have properly formatted data. So it's a comma separated file now with the date, open, high, low, close, volume, and adjusted close. Let's see if we can open this in LibreOffice, and it looks like everything's okay, comma separated. There we go. So we've pulled the data. So one of the things that computers and programs are good at is doing this repetitively. So because you might say, oh, it's easier to just download it manually and then open it in Excel or in LibreOffice. Don't save. Okay. But what we can do now, we can make a function of this. Let's first get rid of the code that we don't need. And this function we can use for maybe other symbols. Now we're pulling this symbol, but we could also make a function that we could just give the symbol and then pull the data. And that can be done easily like so. So we do the define function. We can call it get wait a second, get data, and then use a ticker symbol as the argument, and then we indent this code like so. And then if we call this get data, and then we have the same situation as before. So let's change this a little bit. Let's say we want to get Apple, for instance, and then this ticker needs to be replaced here. So here we will use the format function on text. So we use the placeholder, the opening and closing of the curly brackets, and then at the end we do dot format, and then we say ticker. Let's go back. Oh, there we go. So now if we run this, it will get the data from Apple. Maybe we should change our code a little bit, because now we store it to this file, Yahoo Finance.csv, and make this maybe Yahoo Finance underscore and then the ticker symbol. Dot format, and we do ticker. So now we have a function that pulls data from Yahoo Finance and saves it to a CSV file with the ticker name in the file name. So let's run this. Let's see if we get this file and if everything is okay. Okay. Okay, it gives a 404. Did I have a wrong ticker? I think so. Apple is a... No, let's see. Let's look up Apple. Let's do... Yeah. PL. Maybe it has to be capitalized specifically. AAPL. Let's run this. Not found. Let's print out the URL to see what's if we made a mistake somewhere. Okay. AAPL. Oh, I see we have the caret symbol in it, and that's still part of the S&P 500 ticker symbol. So this needs to be removed. So if we run it like this, it should work. So let's run it. And there you have it, no errors. And let's see, we have the file. We have here Yahoo Finance AAPL. Let's look at it. And there we have it. Is this different from the other one? Yes, it's different. So here we have an example of a function that can be called and get the data from Yahoo Finance. To elaborate on this, we could also call this repetitively, this function, by looping over a list of symbols that we want to fetch. So let's do this for the ticker in tickers. Get the data for the ticker. And then let's make a list of tickers. So the tickers our AAPL. IBM, I believe, is a ticker like so. And what else do we like? Samsung maybe, or the Boston Beer Company, SAM. Let's do that. SAM. So let's see if this will work. We should have 1, 2, 3 files being created, and let's run it. No errors. Let's see, we have the files. We have IBM, SAM, and Apple we already had. So let's look at SAM. What kind of data is that? Okay, there you have it. So this is a way to do something useful, like pulling data from Yahoo Finance and store it on your computer so you can use it later. I hope you found this interesting and helpful. If you did, please leave a thumbs up and leave some comments. And thank you for watching, and see you in another video.